Now we will try to identify what are the language represented by the following grammars. Okay, to identify the language represented by the following grammars. So let us take number 1. So it is given that S2 0 S1 or epsilon. So what is the language you can generate? See, you can generate if you replace S by again this term, so you are getting this and this one. Again S by 0 S1, so again you can get this. Okay, so you can keep on writing replacing S by 0 S1 and finally replace S by this epsilon sign, so you will get what? This. So you see that the number of zeros is 3 and number of 1 is 3. So that is, and also after 3 zeros there is 3 ones, that is 1 followed by 0. So what are the language you are generating? It is generating 0 to the power m n, 1 to the power n, because number of 0 is n, that is here 3 and here also 3. So these both are same, n and n, for all n greater than equal to 0. Okay. Next, let us take another example. So what are the language we can generate given that 0s1 s1, suppose 1s 0s and or this epsilon sign. So what are the language you can generate? Either you can take this one or replace s by this epsilon, so you are getting 0 1. From here you are getting 1 0. Okay, and if you go on replacing all these things, you are getting 1 1 0 0 and so on. So this is the language you can generate with this particular grammar. Okay. Now again for, let us say number 3. So it is given that S2, suppose 0 S 1 1 or 0 1 1. So what are the language you can generate? You can easily identify that the language you can generate is, so replace S by 0 0 0 1 1. So you are getting 0 0 1 1 and these 2 ones over here. Okay. So what you see that you are seeing that number of 0 is 2, number of 1 is 4, that is double. Okay. So what is the language you are generating? So language you are generating, number of 0 is n, hence then, and also the number of 1 will be 2n because it is double of n. Okay, you have seen this, where n greater than equal to 1. Okay. Let us take another example number 4. So let us take S2 0 S, sorry, AS A or BSB or epsilon. So what are the language? So either epsilon or replace this S by epsilon, so you are getting AA. Replace this S by epsilon, you are getting BB. Okay. Next you get replace S by BSB and finally S with this epsilon, so this one, or you can get this one. Okay. So you can keep on getting all this here. So ultimately what you are getting, it is C, this is the nothing but it is a palindrome. So you are getting a palindrome. Okay. Now another question, I say what I can say that find the grammar that generate all string of A's and B's including epsilon. Okay. So it is given that find the grammar that generate all strings of A's and B's including epsilon. Okay. So find the grammar that generate all strings of A's and B's including epsilon. So it is nothing but like this, A plus B whole star. So what is the grammar corresponding? It is this or this or A or B, and including this, so this one. So this is the grammar. Okay. So another problem is given like this way, that each string starting with A and ending with B. So find the grammar. Each string starting with A ending with B. Okay. So starting with A, ending with B. So starting with A, ending with B, and in between any string combination of A and B. So let us consider this as A. Okay. So now where A will be anything, it may be this, A may be this, either this or this or epsilon. So this is the corresponding grammar. So this is the corresponding grammar. Okay. Fine. Now if it is given that number 7, each string starts and ends with same symbol. Okay. So each string, here each string start with A and ending with B. Now it is given that each string starts and end with say different symbol. Okay. So this is the same, starts and end with different symbols. See, here start with A, ending with B, that is a different symbol. Okay. So in this case, if it is given that find the grammar, okay, find the grammar where each string start and end with different symbol. Each string start and end with different symbol. So start and end with different symbol. Okay. So let us consider start with A, end with B, or it start with B, end with suppose A. It may be whatever may be the symbol, and where A is nothing but this one or this one or this one. So this is the corresponding grammar. Okay. Fine. So now this is case of start and end with different symbol. Now if it is case of start and end with same symbol, then what will be the scenario? Start and end with the same symbol. Okay. Now start and end with the same symbol means start and end with the same symbol. So this may be one possible solution, or this may be another possible solution, or this A start and end with same symbol, or this. Okay. Where you can say A is nothing but this one or this one or this one. So this is a corresponding grammar. Next problem, we can say that find the grammar of length of the string which is exactly 3. Okay. So what will be the grammar where length of string is exactly 3? So length of the string will be exactly 3. So let us consider this is the length of the string 1, 2, 3. Okay. Where A is either A or B, and you can, if you replace this capital A by, sorry, this is A, this is capital A. Okay. So if you replace with capital A with either A or B, you will get ultimately a string consist of A and B whose length of the total length will be 3. Okay. Now suppose number 10, what to write? Okay, here. Fine. So if it is given that length of the string will be at least 3. At least 3. Okay, at least 3 means length of the string will be minimum 3 and maximum anything. So what will be the grammar? So minimum, this is the minimum 3, and if you want you can increase. So at least 3 means minimum length of the string will be 3. So A will be either A or this, and B will be this or this or epsilon. Now if you replace with epsilon over here, you will get minimum 3, and if you replace B with any of these 2, you can generate the string as much as you like. Okay. Now suppose if it is given that the length of the string will be divisible by 3, so it will be divisible by 3. So what is the grammar? So like this. So if you replace s with epsilon, you will get AAA. The length of the AAA is 3, where you can say that A is either A, or you can say that A is either A or B. Similarly, another solution of this problem is like this way: A to AS of epsilon, A to BBB, and B to A or B. Okay. Now, number 12. So language is given A to the power n, B to the power n, where n greater than or equal to 1. So what is the grammar? So grammar will be nothing but this: A capital S B, where another is AB. Okay. Now another is given, number 13. Let us see. L is given that A to the power n, B to the power n, C to the power m, n m, where n m greater than or equal to 1. So corresponding grammar will be what? Let us see. S2, this is AB. Okay, fine. Now A is this one or AB, and B is CB. This is kept small c. Okay, small cb, and this is small c. Okay, so this is the corresponding grammar of this particular language. This is the grammar. Okay, fine.